So this is a working collaboration with Lorenzo, Luis, and Eleonora. Lorenzo is a student, a PhD student of Luis and Eleonora together, and I am the one learning from all of them about the subject. And also Lorenzo will be on the market soon, so if you want a great postdoc, he's a very good one. Okay, so let me give the idea of what's behind the talk. So the idea is that of understanding the relation between particular sister actions on varieties and some special type of Mori dream regions that are two-dimensional. So relation between particular set and two-dimensional Mori dream regions. I will define everything because there are several definitions about all these objects and they are not always compatible. So I will give our setting so that it's clear what we are doing. So let me first recall the objects. We work over the complex numbers and we consider y, normal and projective variety. Okay. And recall that a small modification of y is a birational map y that goes from y to y prime with y prime still normal projective. And small means that it is an isomorphism in codimension 1. So usually we keep the classical terminology. So we say that what phi is an SQM, in general, a small q factorial modification. And adding the requirement that both y and y prime are q factorial. So in particular, we want that every Weyl divisor is q Cartier when we talk about the variety. So fix y is above, and let me introduce one ring that is very familiar to birational geometers. So let us fix a finite set of effective Cartier divisors. Let's say effective Cartier divisors on Y. Let's call them L1 to LK. And then we can define this ring of multi-section, multi-graded ring, R of Y, L1 through LK, that takes all the possible combinations of such divisors and all the possible global sections associated to the combination. Okay. This is a multi-graded C algebra. And there are a bunch of definitions related to this. So for example, if you take a set of generators of the effective cone, if it is finally generated, and if this is finally generated itself, then you have that this is a Mori dream space, and it's used in the set of minimal model program. It's one of the best places to work with. But we are not interested on that for now. So we will do only local geometry on such ring. So for that, I will give you the second definition. So this is standard. The second is not. It is sort of standard because several people gave a definition for it, but it changes in the literature. So that's why I say definition. So let C equal L1 to LK, a rational polyhedral cone. And the rational polyhedral cone I wanted in the set of Cartier divisors of Y tensor with the rational numbers. And I want such divisors to be effective as above. Then we say that C is a Mori dream region if the multigraded ring defined as above is a finally generated C algebra. And I will say that this definition goes officially maybe to Okawa. But there are different ones and they change in the context. But yeah, I think that he is the one that gave the better description of what can go wrong and how when it works. So this is the first one. And the second definition, that is the one that we will be interested in today, is a special case. That is the two-dimensional one. So let Y normal projective let's pick two Cartier divisors, right? Such that, and then we add some more constraint just to make the construction better. So we want L1 to be ample. And we want the multigraded ring. No, sorry. We want R of Y L2 to be finally generated. And even more, we want phi from y. And now, if the section ring of L2 is finally generated, we can consider the proj. So it makes sense to consider the map natural that goes from y to y prime, given as the proj of this finally generated C algebra R y L2 is a small modification. Then, in this case, we say that L1 S2 is a merging pair. If the pair L1 and 2 is a Mori dream region. So we are requiring lots of things, but it's not too bad. So we just to give a picture. So we have the effective cone. Inside of it, we have the movable cone. The ample cone. And then we pick an element in there and a second element outside. And we want this segment or this one-dimensional cone to be the origin region. Okay. So this definition is the starting point of our connection. And before starting the connection, we need to jump now from birational geometry to sister action. And so let's see how this connects to sister actions. Allora, the first step is the step 1 is the Bionichi-Birula decomposition. Allora, let's see how this works. So this is quite technical, but it's important to introduce it so that we sort of see how the things go along. So we fix a pair XL, the polarized pair, with X as above normal projective and L ample. So we'll have a different role. And assume that the pair the action admits a linearization on the line bundle. So what it means is that if you can construct a commutative diagram, so you have the action on X, and the action goes up to L, and the action is linear on L. So basically, on each fiber is just multiplication by a scalar. So it's really nice. And this diagram is commutative. Okay. So when we have such an action on the variety, whenever you have an action, the natural thing to consider is the set of fixed points. And the B-unique Birula decomposition gives a decomposition of the fixed locus components of a sister action. So given the action, consider the set curly Y of reducible components of the fixed point locus. So what we can do, since the action admits a linearization, we can assign to each fixed locus component a weight. So, and assign a weight to each Y. What you can do, you can restrict the action to a fixed point of the fixed component, and then what you do, you just restrict the action to a fixed component, and what happened? You can assign a weight to it, mu L of Y, in the set of character corresponding to the action of C star. And this is just isomorphic to the homomorphism from C.
Sorry, Stefano, you've lost your microphone again.
Oh, sorry. Is it working now?
Yeah, that's perfect.
Okay, sorry. As I said, EdROM sometimes it goes down. So I've just said that you can fix you have these fixed loci components, and then you take one single component, and to each single component you can assign a weight that at the end it ends up to be an integer with this isomorphism. So we can think mu L as an integer and call such values critical values. Okay. So what B-unique Birula proved is that this set is finite. So it's a finite chain, is a finite chain of values, A0, A1 to AR, and we can define an object called AR minus A0, is delta, and is the bandwidth of the action. Is the criticality.
Stefano is still here.
That have value AI. So
Sorry to interrupt you again, but I think I lost you now again. Sorry.
Sorry.
Okay, now I can hear you again. I saw your mouth moving, but I could not hear you. Sorry. But now I hear you again. Sorry.
Yeah.
Keep going.
No, when I see your that the initial and the terminal values are irreducible. Sorry, the initial and terminal components are irreducible. So this will be y plus, and this will be y minus. Okay. So we have these initial and terminal objects. We have some components in the middle, and then it makes sense to recover the variety itself, looking at where the points go under the x plus of y to be the set of points of the variety such that the limit as t goes to 0 of tx is an y, and x minus of y, the limits t goes, infinity of tx is in y. So basically, for example, you start with x plus, and you go all the way till it stops. And you go this way. And in this way, you sort of recover all the points with these properties. These are called the unique Birura cells. Okay, what is known? is that both x plus or y plus and x minus or y minus are dense open. Subsets on X. Okay, so this is the first thing. Then from this, we want to construct GIT quotients. But now it is sort of clear what we are going to do. So we have all these C star plus the two joins, the two limits, at 0 and at infinity. So what we're going to do, we are going to remove the things that are so for any index, that goes from 0 to r minus 1, we write y, all the elements y in y such that the weights are less or equal than ai is joint union the y's, the weights greater or equal than ai plus 1. So we basically disjoin the things, and we write xs I plus 1 to be given as x minus y in y plus of x minus of y. And this is open in X. Null the component okay, now it appears. So you decompose in this way. You have y minus, y plus. You have three sets, three ways, 0, 1, 2. And then you decompose, putting off the two limits, and all the things are maybe on the left of one of the fixed point components. And the GIT quotients are defined as this I plus 1 over the action of C star. rational number. So if you fix any rational there, you can rewrite this as a proj. Is a proj for m greater or equal than 0 and m tau in Z of H0 x ml of m tau, where this is the weight of the sister action. So basically what you do, you decompose this. You have a natural way of writing these quotients, and you can see these quotients as a proj of some graded algebra. Okay, let me just add two definitions and let me at least state the results and then maybe prove something. So we cannot use the old machinery. We have to restrict to have some good things. So first of all, so we pick XL polarized with a sister action of criticality R. Okay, we have two added things that we will need. The quotients associated to the first map and the second map are just x minus and x plus. Isomorphisms. So basically, when you cut in the picture at the good point, then basically you obtain all of y minus. So if you take all the things that go there as a, so if you take all the possible fibers of the actions and you collapse them, you basically obtain y minus if you cut on the left, and then you obtain y plus if you cut on the other side. This can be resolved easily because it's just a blow up, basically, if it doesn't work, but it can happen, so we just don't want it. Even because in birational geometry, whenever you do a blow up, you change the everything. You change the cones, you change the N1, you change peaks. So you don't want to blow up. You want to start with a good setting. And second, we said that the action is a bordism. If it is of B type, so you start with the thing on top. Could I mention one subvarieties? For every inner component. Here it is. For every element of this form, you don't want this locus to be divisorial. Okay, remark. So given a bordism, then psi that goes from G X 0, 1 to G X R minus 1 R. Okay, so the map from what it is y minus to y plus in this way is a small modification because the inner quotients that we do not, basically the points are semi-stable, are always dense enough, and they cover everything but a codimension 1, not less of a locus that is less than codimension 1. Okay, let me recall one more thing and then we're done. And then we start with the correspondence. Theorem of Wisniewski, Occhetta, Romano, and Solá Conde. Not in alphabetical order because worse is better. So given a birational map, phi from y minus to y plus, we say that a geometric realization so a normal geometric with sync. So the limit as t goes to 0 and as t goes to infinity, y minus and y plus. Phi. Okay, finally, I always go back because I am really ignorant about sister actions, so I always have to repeat all the construction to understand what goes on. But let's finally give the correspondence. Okay, the first one. The first one is the one that goes from merging pairs to sister actions. So we start with a map phi. It goes from Z1 to Z2, a small modification. we take L1 that is ample on Z1. So we take a small modification. We pick an ample divisor on Z1, and then we see we pick another ample divisor on Z2, and we pick its pullback on Z1. So we say that L2 is equal to phi upper star of L bar. Let me say L bar ample on Z2. So we have two divisors on Z1. One is ample and one is not ample anymore because it's inside the ample cone of a small modification, so it's outside. But what we want is that the multigraded algebra given by the two is finally generated, such that A, the sum as A and B greater or equal than 0 of J0 of C1 AL1 plus EL2 is finally generated. Then theorem. Also here we switched because we like easier things. So is a theorem where is one of the theorem with Lorenzo, Eleonora, and Luis. So there exists in the setting normal, projective, variety X with a sister action. Such that first thing, the action is a bordism. Second, the sink is what is the sink is Z1 and the source is Z2. So we have the two things are the same. And third, this is a geometric realization. So phi coincides with psi. Okay, I went really slow. I want you to try to give at least an idea of how it works, and then I want to give the other correspondence. But let me be just quick on the construction of X. Because this is not too bad. So if you pick H, the homomorphism of Z L1, L2 to C star. So this is a complex two-dimensional torus. And this torus acts naturally on the algebra A. It's 2D and it acts naturally on A. So what you can do is that you can fix one colattice element. So of L1, L2, the character lattice. Then what happens is that the choosing alpha the choice of alpha induces a natural subtorus. H prime on H, and on the algebra A. So we can rewrite A as A alpha given as the sum as m for m greater or equal than 0 of A alpha m. And now let me make explicit what this A alpha m is. With A m alpha in z greater or equal than 0. Okay, so we can decompose in this way. We pick two integers, mi, such that the value of m1, L1 plus m2, L2 is equal to m. And then we write h0 of y1, m1, L1 plus m2, L2. So this algebra is finally generated by assumption, and we can define x alpha to be the proj, but now the proj is the proj of A alpha. And there is a natural sister action on X alpha given as the inclusion of this subtorus H prime into H. So we have an inclusion of H prime into H given by alpha. This is a quotient subtorus H second, and this H second acts on X alpha. Opposite side. So as above, let X Okay, I'm not really lucky with the connection today, I'm sorry. So we take a polarized pair with the Sierstedt action, X normal Q factorial and projective, L ample Cartier. Assume as before the criticality is R and all the other things. Then we obtain theorem, the induced rational map psi from y minus y plus is a small q factorial modification and the pair, sorry, L minus L plus with L minus equal L restricted to y minus. And L plus, it's a bit more complicated, is the P push forward -1 of L restricted to L plus, to y plus, is a Mori dream pair. Use natural associated map is psi. Okay, I don't think I have time. And we hope that this will give a better understanding of the local geometry of the Okay, so if you're lucky and you go from a nice point to a nice point, then you obtain everything q factorial. But if you are not lucky and you pass through a wall, then q factoriality fails. So there is some really uncontrollable things to be careful of. So I think I can stop here. Then maybe if you have questions, I am here to answer.